Welcome, everybody. This is our live public series of sessions we call Stranger Danger. This is a public series open to everybody. And today we have the great and good Sonia presenting our JavaScript Stranger Danger. Your attack surface just got bigger.
Hey,
Sonia.
hi everyone. Hi everyone. Welcome. I'm Sonia.
I can't hear you, Sonia. That might be me.
Oh,
Keep going. I'm sure everybody can hear you. I'm going to remove myself.
Hi everyone. I'm Sonia. I'm a senior security advocate at Snyk, and I'm going to be taking you through today's session. Stranger danger, your JavaScript attack surface just got bigger. Cool. So let's. So what are we going to talk about today? So we're going to look at the current state of the open source software. What are the hot topics? We're also going to talk about the iceberg. And you might be like this little emoji thinking, what is the iceberg? So we're going to have some live hacking session, and with the help of Patch is our mascot, the little dog. Obviously, we're going to see how we're going to remediate and how we're going to fix those vulnerabilities and see the learnings and a little bit more around defense in depth. Cool, so let's start with the current state of open source security. So first of all, we know that organizations of all sizes are heavily reliant on software. And we know that much of that software supply chain consists of a lot of open source software components, which means that OSS has cybersecurity implications. We know that that's an attractive entry point for people and organizations interested in theft, disruption, or exploitation for economic or political gain. Thus, the attack surface is changing, which means that we have to change the threat models in cybersecurity. And also, we've seen that defects in small libraries can cause systemic risks. And we've seen that with incidents such as Log4Shell last year. So vulnerabilities can originate from something as simple as configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for a business. One recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw, and 20% has a severe vulnerability within those. While we know that not all these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate software. And we have organizations such as OWASP, which stands for Open Web Application Security Project, that track those vulnerabilities found. And they provide a list that developers and security teams can use as a starting point for their application security program. The most recent OWASP Top 10 list was released in 2021 and included vulnerabilities like broken access control, injection attacks, security misconfigurations, and other. So let's have a look at some open source software attacks. The first one is typo squatting attacks. Typo squatting attacks take place when bad actors push malicious packages to registry with the hope of tricking users into installing them. This is really similar to website phishing attacks that exploit typos made by individuals who may accidentally type in a wrong address. Here's an example with the package React with a typo. In that case, you will not install React, but a malicious package that has a completely different end goal. Another example is malicious packages. In that case, they will inject malicious code into a software product in order to compromise dependent systems further down the chain. So in this example, we're having a package called Fall Guys, and usually the malicious actor will try to surf on trends. We know that in that case, the game Fall Guys has been quite popular during the pandemic, and user might think that by downloading this package, they might have an advantage in the game. Might be probably something like cosmetics or changing your character skins and all those kind of cheating advantages. Fall Guys is a malicious package in that case that contains malicious code that attempts to read local sensitive files and exfiltrate information through a Discord webhook. So the Discord webhook was the entry point in that case. The code attempted to access specific paths available on Windows system. Basically, it was looking for the local storage path and looking at the level DB. One last example is compromising maintainers, where malicious actors will use social engineering methods to gain access to open source projects. So here we have an instance with the event stream package where the malicious actor did some social engineering on the maintainer. So basically, he was going through all of the issues that they had on that repository and looking for an opportunity to add a new feature. So at first, he pushed some cosmetic changes at first to build up the trust with the maintainers. So he pushed some changes on the README file, on CSS files. And then once he got more permissions, he pushed the malicious payload into the code base. In that case, it was targeting a Bitcoin wallet. But his modus operandi was really interesting in going through all the issues and see if he can contribute, building up the trust, and then push his code. So all of this is known as a supply chain attack, also called third-party attack. It occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. It doesn't affect only JavaScript packages. This is a known issue for all ecosystems. We had a recent example last year with Log4Shell within the Java community with a vulnerability in the open source Apache login library, where one of the Log4j exploits allows remote code execution on servers running vulnerable application without requiring authentication. That has enabled the and earned the vulnerability severity rating of 10 on the CVSS scale, which is the common vulnerability scoring system. So Log4j is used in many commercial applications, and organization might be vulnerable without knowing it, that they're actually using the logging library. Supply chain attacks are attractive to hackers because when commonly used software packages are compromised, the attackers could potentially gain access to all the enterprise that use that software. So let's try to understand how this is possible, and let's say hi to the iceberg. Oh, by the way, if you're confused by the statement, let me explain it to you. So that's the iceberg. And this is our starting point on the iceberg, the tip of the iceberg. This is the application code. This is the proprietary code that we write in an organization. Does it bring security vulnerabilities into our code base? Maybe, maybe not. In that example, we're having a NoSQL injection because we're not sanitizing the user inputs. So basically what happened here, we do have a function signature of an express application with a function that has a request, a response, and the next callback. So it's trying to call the user table or collection, which means that there's a database behind the scene, and it's trying to do a login. It's looking for username and password. So what are the vulnerabilities here? What can go wrong? So here, as I mentioned, we're having a database injection, is more commonly known as a NoSQL injection because we're using MongoDB. And the applications which are built with Express, they use body parser to parse the JSON object. And it takes whatever you send to and convert it to a JavaScript object. If the request has a username and a password, this is going to be part of your JavaScript object. And if you're using MongoDB and you add the $sign with greater than as a key and an empty string as a value, then the JavaScript object will tell MongoDB to do a greater than match to filter all the results, and basically you'll be logged in as an admin. So they show the importance of sanitizing the inputs and to handle this as soon as possible before it's stored in your database. So we start with our code where potentially we can have security vulnerabilities. This is a piece of code to import a dependency, which is a nice segue to the layer below the application code on the iceberg. So the open source code. If we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, well, we don't want to reinvent the wheel, and this is totally understandable. Why would we want to waste time to rewrite something that might probably exist as a package in our ecosystem? That's what we have here with the marked package. So marked is used to as a package used to have markdown enabled within your code base, and then you can use it for your application. But we're now bringing several packages into our code base, not only one, but several. And that's increasing the attack surface and introducing new risks. I do have a few questions for that. Are we aware of all the packages that we have in our code base? Are we aware of all the dependencies and sub-dependencies that we have? Do we have a good understanding of indirect and transitive dependencies? Do you also have tools that help you having that level of understanding and visibility? And what are the risks when you bring a dependency into your code base? I know that's a lot of questions, but let's see some numbers around that. So we know there's some cybersecurity challenges in our open source software ecosystem. We can see that around 5 is the average number of outstanding critical vulnerabilities in the application. This will depend obviously on the programming language. We also see that we have 80 top-level dependencies per project, and also this will depend on your programming language. But the most concerning one is the last one. The average number of days it takes to fix a vulnerability is almost around 100 days. So enough chatting for now, and let's move on to hacking an app and understand more about how dependencies can impact your application and introduce vulnerabilities that you're not aware of. So I'm going to use this application called Patch To-Do List. So this is basically a to-do list. I'll just enter some input. So feed patch, walk. I can write walk patch. So you can see this is like a regular to-do list that you could expect. But this to-do list is also using Markdown, because we do have marked the packages that we mentioned earlier on that. So for those of you who don't know what Markdown is, so basically it's a programming language that allows you to prettify your what you're doing on your application, so you can implement headings, you can create paragraphs, you can create links, and all of those using the Markdown language. So let's try using bold, for example. If I can type right patch, this should be bold. Yeah, this is bold. Cool. Let's try with some links. By the way, if you have any ideas of how we could tamper with this input and try to perform a vulnerability, exploit a vulnerability, don't hesitate, drop it on the chat. So here I'm creating a link. So this is how you would do a link on using Markdown. I'm just going to zoom a little bit. Cool. And yeah, if I right click here, this will redirect me to the Snyk website. Yes, so this is working. We can create links. So let's try. I'm going to put on my attacker's hat, and I'm going to put the regular alert scripts. Let's see if this works. Oh, okay. So there's some sort of sensitization in place. Let's try with the JavaScript protocol. So I'm doing again the link, but this time using the JavaScript protocol and having an alert patch. Okay, there's a little bit of sensitization going on here because we only have the closing parentheses in that case. So there's some sort of filtering. Because I wanted to try with the JavaScript colon, or you can try with VBScript colon, just to see if this could potentially be a vector of attack. So this is a good start. It's not enough, but let's try different things. So I'm going to try with HTML entities. So I'm replacing the colon with this and the closing parenthesis with this. So if you're asking yourself, what is entity HTML entities? So basically, it's a piece of text string that begins with the ampersand sign and ends with the semicolon sign. And there's quite a list actually to do this. So what I'm using the colon and the closing parentheses, as you can see here. I'm just going to zoom a little bit more. So for the closing parentheses, this is the one that I'm using, and there's the colon. That's the one that I'm using here, trying to perform the attack. But it's basically the same that I've tried before, but we're replacing the colon and the closing parentheses with this. Oh, it's completely gone here. Okay. That's probably something that we could have a look at. So let me try something else. So in that case, so I'm still using HTML entity, but I'm also using the this keyword. So I'm using the this keyword. I'm trying to break out of the logic because I've actually tried several conditions, and I can see that in the backend, there's something blocking us from hacking this application. So maybe the condition is expecting exactly the JavaScript colon protocol, but in that case, we're encoding it with this HTML entity. And also we're adding the valid keyword in JavaScript this. And you can replace it with window or document. This should potentially work. Let's see. Yes, it is working. Cool. So what's happening here? We're using two things, the HTML entities as mentioned, and the fact that the browser permissiveness that enables the vulnerability. So if I go back to what I've entered. So this is not a valid HTML entity. We're just combining the HTML entity with this keyword, but the browser interprets the colon as an HTML entity, and then the markdown vulnerabilities allows it through the sanitizer. So as an attacker, it will give me a valid way to write JavaScript and perform the attack. So I can do other things with this thing, and basically this allows me to break out of the logic that is preventing the JavaScript to be executed in the backend. So that's the first step for an attacker when testing an application. They'll see if there's an entry point, and then they will craft a better payload. Because you might ask actually and say, well, Sonia, this is not really concerning. It's just an alert. Yes, you're right. But let's just refresh this page and realize something. This is actually stored now on the application. So this is a store cursor scripting. This is stored in the database. So if we think of this application as social media, or if you have a profile, then visitors could click on some of the links that you have on your profile, and on the back end, the data will be sent to the attacker servers, and it could potentially contain sensitive information. So you can do the same with cookies, with sessions. So you get the idea. Cool. So why do we have this? So let's have a look at the code. So we know that we've been using marked. Just gonna zoom in a little bit here. Cool. So just closing here. We're using marked here, and we're instantiating it. Where are we? Here. Cool. So we can see that we did a little bit of due diligence here. We've set the options for sanitizing to true, but it's not enough. So let's ask for patch help and fix this vulnerability. So you can use Sneak on the ID integration. I'm using Visual Studio Codes, and if you click on the marketplace icon and then you type Sneak, you'll have the Sneak integration. You can enable it, and then you have to reload your ID to take it effect. And if you click on the patch icon the first time, you won't have that screen. You'll have a different one, which will ask you to authenticate to your Sneak account. You can do it for free. And then when you're done, you can run your first scan. Cool. So what we're seeing here, if we go back to the, I'm going to go to the package.json here and having patch on the side. Cool. So we can see here all of the vulnerabilities that we have within the packages. There's quite a few around that. We can see there's some here on marked. But what we can do is looking at marked here, and we hover over the package and click on the yellow light bulb and show the most severe vulnerability. It will come back with what we actually experienced on the application, the cursor scripting. So this has been introduced with this version, and it can be fixed with that specific version. Cool. What we have a little bit more information around the package. So what is the definition of marked? We can also see the payload that we've been using to perform the attack on this application. And we have a little bit more details on what is a cursor scripting attack. So basically this occurs when the attacker tricks a legitimate web-based application. In that case, this was the patch to-do list to accept a request as originated from a trusted source. And in our case, we're having a stored XSS because this has been stored in the database. And when I refresh, and if I share the link to anyone, this will be stored and visible for everyone. Cool. So let's fix this vulnerability. So we know we need to upgrade the package to this version. So let's do this. So I'm going to go to marked and just do this. Cool. I'm just going to close the server and do an npm install. Hopefully this will do it quickly. So what we're expecting is by upgrading the this specific package is to remove this vulnerability. So okay, let's go back to the server, just start again. Cool. Okay, and let's refresh. Oh, it's gone. Cool. Let me just for the sake of the presentation, just do it. Just going to remove all of this. The malicious one, just keep the nice and clean. And do another one. And yeah, this is fixed. We can't perform this attack anymore. So thanks, patch. Also, what you can do to make sure that you fix the vulnerability, you can rerun the scan here, just like by clicking this little icon, it'll go through again your package.json and let you know if there's any more vulnerabilities around these packages. Cool, and this has been fixed. Okay, so let's see another entry point on this application. Just gonna remove this. Cool. So if we have a look at this application, there's also this URL bit. So let's see, what could we do with the URL? So we can try to access the sensitive file. This is usually what one attacker wants to do, is just to access credentials or passwords, or just understand a little bit more around the application architecture. So let's have a look at this URL. If I put public here, I do have access to the files that are within the application. So it's like some JavaScript files, have CSS, we have images. Okay, it's not great, it's not good practice, but let's see if we can go up and go to the parent folder. So let's do with the // and we're back to the front page, the home page, the to-do list. Okay, well that's probably a good news. There's some sort of sanitization on that side. But let me put back my attacker's head and let's try something else. I'm going to try URL encoding this // So if I go back with public and then I'm URL encoding. So here, instead of having the dot, I'll have the %2e. Instead of having the slash, I'll have the %2f. So let's try this. And interesting. Okay, so this is working. So what do we have here? So as an attacker, I can start like navigating and having a look at the different files. This is interesting. Let's have a look. Ooh, passwords. Okay, MySQL database, interesting. And Dockerfile. Yeah, this will give the attacker a better understanding of the application. But let's say this is not enough. I'm a really curious attacker and I want to see what's on the server. So in that case, this will be my local machine, obviously. Let's try to go up to the parent folders. And okay, can still perform this. This is interesting. Let's keep going up to the other parents folders, and oh my, we do have access to the etc folder. So I'm not going to click because I don't want to show sensitive information. But by clicking the etc, you can go to the password folder, and yeah, you get the gist of it. This is not great. You have access to sensitive info. Cool. So what is happening here? So let's have a look back in the code. So if we're looking at the application, the app.js file, so we're using st the package to actually take care of those static assets. So we're instantiating it here, and we're setting it here. Yeah, so we're using it here, and you can see with the URL we're using public, and we've seen it that from public we could have the architecture of the and more information on the application. Cool. So let's see on the package.json if patch can tell us what is going on. So I'm hovering the st package here. I'm clicking on the yellow light bulb. And what I'm having is directory traversal. Cool. So this is introduced with this specific version, and it will be fixed with that specific version. Okay, so what is happening? So the versions prior to 0.2.5 didn't properly prevent path traversal. So we've basically done this. The request like this payload would leak sensitive files and data from the server. And what is happening? So directory traversal attack, also known as path traversals, aim to access files and directories that are stored outside the intended folder. So if we do the // sequences and variations, as we've done with this with the %2 and %2f, or by using absolute file path, it may be possible to access arbitrary files and directories stored on file system, and including application source code, config file, and other critical system files. And in that case, we're having information disclosure. Because you've seen we were able to see database passwords. We have access to the etc password. We can also have access to the SSH ID RSA and other credentials and passwords. Cool. So we don't want that. So let's fix this. So what they said. So I need to bump the version to this specific one. Okay, let's go back to the package JSON here. Okay, let's go back to st and let's change the version. Cool. So I'm gonna stop the server, do another npm install. So again, what we're doing here is by upgrading this specific package, we're hoping to fix that vulnerability. So let's start again the server. Cool. And if I go back to the page, here, I'm just going to refresh it. Yeah. Cool. So you can see that I can't get access to that that path anymore, to that specific folder, which is good news. So yes, yay, patch helped us to fix this. Great. Okay, let's go back to the homepage, and I wanted to demonstrate another attack that is typical from the JavaScript ecosystem. So let's go. Just going to close this here, and we're going to go to the routes here. Cool. So this application is not only a 2D app. There's a lot more routes that we're using, and one of them is around a chat app. So if we have a look at the, if I can find it, the chat endpoint. Oh, here we are. Cool. So this chat endpoint basically what it is. So if you're a user, you'll be able to create a message, but you'll not be able to delete a message. And if you're an admin, obviously you can create messages, but you also have the ability to delete messages. So if I go to the chat endpoint here, so at the moment we have an empty array because we haven't created any messages as a regular user. But what we can see here is we're actually using Lodash, and more specifically the merge function. And this is the important bit actually that will help us manipulating this vulnerability. So let's use, just going to open the terminal, make sure that cool. So first of all, for sanity check, I'm just going to curl the page. So for those of you who are not familiar with curl, I'm using the get requests to the endpoint. So this is the chat endpoint. So I can show it. Yeah, here. Cool. And it's coming back with an empty array. So this is what we have here. So we're good. Okay. So now let's try with let's start creating a message. So I'm using the put request with the same endpoint. I'm using the header of content type application JSON, and the data that we're sending is a user, which is a password, and the message is hi. Cool. And oops, sorry. And it's coming back with okay, true. So here we should be able to see it. Yes. So we have a message of ID1 with hi. Cool. So let's do this a couple more times. And if I refresh, here we have a few messages. So we're still a user, just sending messages. So this is cool. But I mentioned that as a user, I'm not supposed to be able to delete messages. So let's try with this one. So I've done the same request, but this time using the delete request on the same endpoint. And with the on the data, I'm targeting the message. I want to actually delete the first message, basically. And it's coming back with access denied, which is the expected behavior, because you're, as a regular user, you shouldn't be able to delete messages. So let me put my attacker's hat, and let me try to tamper with this curl request. So I'm going to send a request with put, the same endpoint with the same content type. I'm going to be also a user with password, but this time, because I'm a malicious actor, I'm going to change the text to this noti emoji. And I'm using the proto protocol here, and I'm going to tamper with the can delete. I'm changing it, the flag to true. Cool. So this is coming back with true. And if I refresh here, I have the malicious message here. Okay, so I've been added as malicious actor here. And now I'm going to do the same and try to delete this. So at first I wasn't supposed to delete because I'm just a regular user, but here I'm going to try to delete the message number 1 with the ID of 1. And this time I'm not getting the actually the access deny. I'm getting true. Let's see on the page, because the first message should be gone. And yes. Oh, okay. That's a bit concerning. Let's see if I can do this with the other messages. Let me try. Okay. Cool. This is not great. So what is happening here? So as I mentioned, this is well-known vulnerability within the Lodash package. So let's see what is happening. So if I go to the package JSON and hover the Lodash package here, we have what is called the prototype pollution. So Lodash, first of all, Lodash is a modern JavaScript utility library delivering modularity, performance, and extras. And in that case, we're using the merge function. And what is the prototype pollution? So it's a vulnerability affecting JavaScript. And the prototype pollution refers to the ability to inject properties into existing JavaScript language, construct prototypes such as objects. And in that case, using the proto attributes, we can actually tamper with the object and inject. In our case, this was injecting the can delete and change the flag to true. Cool. So let's fix this vulnerability, because we don't want this to happen. Okay, so if we go back to the package JSON and on Lodash, I'm going to upgrade it to 20 and do the same. Have to close the server, do npm install here. So what we're doing here, we're upgrading the Lodash package to fix that prototype pollution vulnerability. Let me start again the server. Cool. And if I refresh this, it should actually, yes, disappear and go back to the initial state, which is the empty array. But just for demonstrating purpose, I'm going to create another text here. Okay, so here I'm just recreating one message. I'm going to try to have the, if I can find the malicious one, just going back, yes. Okay, and I'm going to try to delete the message. See if I can do this with the ID of 1. And I can't do this anymore. As you can see, it's access denied now. It's false. So I can't perform this using the prototype pollution. So I can still inject this, try to tamper with the protocol, but I can't delete anymore. Cool. So what did you learn here? A lot of things. So first of all, what I would recommend is, before adding a package to your code base, is to have a look at Sneak Advisor. So if we have a look at Sneak Advisor, if I can find it, cool. So this is how it looks like. And you can see, if you click on the dropdown, you'll have different ecosystems. So NPM, PyPy, Go, and Docker. So in our case, if we look at marked, this is giving us more information around the package. And we can see there's a lot of information on it, interesting one. And also, surprisingly, this has the perfect health score. Cool. So we can see there's the latest version don't have security issues, which is great. We can see it's a really popular package. We can also have information around the maintenance, when was the last commit, when was the last release, and more about the community. Cool. If we were to, if you don't know which package you wanted to implement, but you still want something around Markdown, if you're just typing Markdown, you can have like all the alternatives and different packages, and then you can make your choice based on the package health. You can see that some packages don't have a good health score. If we look at it, you can see there's some security issues here. It's not too popular. And maintenance was 9 years ago, 4 years ago. So this will help you taking your decision on which one you want to implement within your code base. Cool. Also, depending if you're more familiar with the CLI or if you're using your ID, because I've demonstrated everything through the ID, but you could do exactly the same using the CLI. So if I go back to the CLI here and do sneak test. Oops. Cool. This will query the database. and let you know all the vulnerability. The good thing is you can actually use flags. So if you use the severity threshold flag, in that case, it gives you all the and set it to high. It'll give you only the highs in that case. Severity thresholds equals high. Again, it will query the database, and only comes back with the highs and critical in that case. And you'll have exactly the same amount of information that you have within your ID if you compare with what you have here with the Snyk integration. Cool. You also have that information on the UI. You have that visibility on the Snyk dashboard if you import your projects, and you can monitor your project automatically. If there's any new vulnerabilities introduced in your application, you'll be notified on this dashboard. So what you want to do with this, so you can audit your dependencies. You can also, this will help you to create SBOM, a software bill of materials, which is the full inventory of an application, and help organization understand whether application rely on and identify vulnerabilities or license risks that may impact them. I will showcase the SBOM a little bit later. If you want to fix vulnerabilities, if you want to monitor vulnerabilities, and just to have your application continuously scanned. And you will get the same information as on your ID. So you'll have the detailed path, the remediation, the overview. You also have a link to Snyk to learn a little bit more about the vulnerability. But most importantly, you want to fix the vulnerability. So if you click on this green button, you'll get redirected to this screen where you can cherry pick the vulnerability you want to fix, or you can just bulk fix all of your vulnerabilities. And it will raise a pull request on GitHub. Obviously, you have to double check if it doesn't break your pipeline, but it will give you enough information to make that decision. Cool. As I was also mentioning about Snyk, so Snyk is a free website where you have some short lessons around a specific vulnerability. So in that case, if we're looking at directory traversal, you have a little bit around basics, and you have also sandbox, so you can try to have a go with the vulnerability within your browser, and it's keeping your progress as well. So you don't need to finish everything in one go. You can do it when you can, and you can see there's like progress bar, and yeah, there's like different also ecosystem. I'm talking about the I'm referring to JavaScript lessons here, but you can see there's also PHP, Python, and other programming languages, which is quite cool. So let's go back to our iceberg. So we've seen the application code, we've seen the open source level, and let's now see the containers level. So we know that our application needs to be deployed somewhere, and we're using container and static website to deploy our projects. We have different ways to do so. So we can use Docker, Traversal, Netlify, or cloud providers. In that case, we're adding a Dockerfile now in the equation, which has metadata around your project. So that's an additional layer with modern application. We're running our application as Docker images, and this adds to the complexity and attack surface. So Snyk can help scan your Dockerfile with this. So if you have a Dockerfile, it'll be flagged, and you'll see if there's any vulnerabilities within this image. And let's take a step back and have a look at this quite basic Dockerfile. What's wrong with this one? Well, a lot of things. Let's see them. So first of all, the common software vulnerability here. So when you run on those, they have vulnerabilities that we might probably don't know. This could be around SSH or curl that can be a point of attack. In that case, we're installing ImageMagick, and the vulnerabilities that ImageMagick had was ranging from XML injection to remote code execution for that specific package. Also installing dependencies during runtime, which is here a bad practice to install all dependencies using the npm install. In that case, we would recommend to have the only production flag to avoid pulling dev dependencies and non-deterministic package install. And also, what about the runtime vulnerability? Are we looking at security releases? In that case, from Node, are we looking at the security bulletin? Because if we're picking a large image, it might have many vulnerable libraries. Cool. So if we have a look at the Snyk UI, there's some recommendation for upgrading the base image. So you can see here that the current image that we're using is the Nodes 10.4.0 with a lot of criticals and high and medium. And we can have a look at alternative upgrades. So what we recommend if you're doing multi-stage Docker build is to have for your development stage, you could use a larger image just to test, to experiment, to implement. But when you move to the production stage, to have a slimmer image, which might potentially be free of vulnerabilities. And again, if you go to the Snyk Advisor, you can have also that kind of information. So let me just go and demonstrate that. So here I'm going to change, clicking the dropdown and click on Docker, and I'm going to look for the node image. Here, it's giving you a little bit of information around the stars and number of downloads, which is crazy, almost 4 billion downloads. And here we can look for a specific tag. So if we take a look at node 14, let's like this one. Yes. And then you can compare it with other tags, and you can see which one you want to use, which one you want to fetch and integrate within your project. We've done a Docker image security best practice sheets where we give top 10 tips. And as I said, as mentioned, it's better to prefer minimal-based image and to use multi-stage builds for to use also those smaller secure images. So let me demonstrate the image tragic. So first of all, I'm just going to set the context. So we're going to use the image tragic vulnerabilities. We're going to perform an attack on that one. So this is a package commonly used by web services to process images. So basically, if you want to resize your images, you would use image magic. And because there were so many security vulnerabilities around that, they've actually created a specific dedicated website called imagetragic.com to actually address this and explain what was going on. Cool, so let's go here. So this is an application where it's obviously vulnerable with that one. I'm going to demonstrate the magic tragic vulnerability. Cool. So first of all, let's build the image. I'm just going to make sure that I have Docker running. Cool. Oh, again, I need the double dash here. Oop. I'm using the no cache flag just to make sure that it's not taking, keeping the history from previous builds. Cool. Once we've done this, we're going to run the image. Just probably need some background music here. It's almost done. Come on. Nice. Thanks. Thanks, Micah. Cool. Okay, let's run the image, and I'm going to navigate to the specific URL. It's listening on port 3112. Cool. So as you can see, we have a really fancy application, but that's not really the point here. Is just to demonstrate what could go wrong. So first of all, I need to set the scene here, which is really cool. So let me just split the terminal in 3 screens. Cool. Okay. So the first screen here on my left, I'm going to cd to the exploit folder, and I'm going to spin up a local static server to serve the netcat package here to perform the attack. Cool. I'm just going to minimize this one because we won't need it. Okay. The second one is to actually connect to the Docker container here. So if I do a who am I here, I'm root. Nice. And let's see. So we can see here, this is just the common files that you could find on the application. Nothing too fancy here. Let's set up the last screen. So this is where I would run netcat in listening modes, and I'm going to wait for incoming connection in that case. Cool. So going back here, I'm going to choose the files and go to exploit, this one, first one. Cool. I'm going to resize this one. Okay. So the file that I've just added is this one. So it's basically using the image magic API with the push graphic context here, and you can see he'll fill with URL of the JPEG. But here behind the pipe, you can see that I've created RCE1 file. So let's see let's see if this actually happened on the container. So if I do ls_li, I'm just gonna minimize this. You can see here that I've actually managed to create this file on the container. Cool. So you might say, okay, this is just a file. Yeah, this is not great. Let me impress you with the remote code execution, actually, with the RC2 JPEG image. So this time, when I click resize, you can see that it's actually still spinning here. This is a bad sign. Usually, it's like I'm connecting to the server. Cool. So I'm just gonna type here, who am I, just to make sure it's coming back as root. And if I do another ls_li, you can see that stuff is happening here with magic. There's a lot more files here. This is just horrible. So what are we doing? We have to wait about 10 to 20 seconds for the netcat utility to be downloaded from the local static file server. It will be compiled and executed to then create a reverse shell that allows us to interact with the local netcat listening prompts. So there's a bit of delay here. So as I say, we have to wait like 10 to 20 seconds for it to come back. But hopefully, thanks, Micah. We're root. Okay, we did it. We have a remote shell. Okay, this is a little bit. It's not looking great. So let me check which Python version they have. Okay, they do have Python. So let me just change this shell, the format of the shell. This is way better. Cool. So just to prove it, I'm root on this. I'm connected to the container. Cool. So if I have a look now, I can just navigate and just exfiltrate data. Just gonna go up. So yeah, I can have fun now. So I can have access to root, and I have access to all the other folders. I can peruse and see if there's any credentials, secrets, or other things that I can take advantage on. So yeah, this is just to demo you based on one vulnerability from the ImageMagick vulnerability package. Managed to actually perform RC and have a remote shell. Cool. So let's go back to the iceberg and let's see what's the last layer. So we have the application codes. We've seen that this is our proprietary code that we implement in our code base. We implement a lot of packages, dependencies, which is the open source code level. And we containerize those applications. Cool. So what could be the last layer? Let's think of it. What could be the last layer that we have in that case? Here. So actually, it's the infrastructure as code that we have. And this is an approach to manage data center, server storage, and networking infrastructure. It's meant to simplify large-scale configuration and management because you're provisioning your resources through code instead of manual processes. This is to make sure that your application is scalable and available. You can make your code as your single source of truth, where you specify explicitly through code all the infrastructure specification in your config files, which is great. You can use version control in all of your config files, and you can test and monitor your configuration. So IAC is amazing, but also it brings some vulnerability. And the first one is, unfortunately, cloud misconfiguration. This is the most common vulnerability that organizations might face. And this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. And we have a few examples here at the bottom. So the first one is with PlayStation. There was 77 million accounts that had been hacked because of misconfiguration. There's also one with Uber. We have 57 million customer and driver information breach because one of their repo went from private to public, and some AWS credits were publicly available. Then you can imagine what happened when you get access to AWS credits, have access to your crown jewels. And for FedEx, you have 119,000 scanned docs that were also involved in a breach. Cool. So let me demonstrate how Snyk can help you with the Snyk IC in that case. So what we have here is really basic examples of Terraform. As you can see, there's some definitions around the provider. Here we're using AWS. We have a few definitions around a basic IAM account password policy with some of the rules that are grayed out just for this demo. I'll explain why. Then we have other definitions around VPC, storage, CloudTrail, and keys. Cool. So let's go back here and let's run Snyk IAC tests. Exactly the same. I'm using the CLI commands, and it's going to scan all of your Terraform files and your IAC files that you're using, and come back with some misconfigurations. So in that case, so we don't have criticals. We have 3 highs, we have 9 medium, and 7 low. Okay, let's have a look. So I've mentioned that we're using AWS here. You can see there's like several services. So S3 buckets, CloudTrail has logging disabled. Okay, let's have a look at the password policy, because that's the one that we're gonna try to fix. So we can see here it's on the medium side. So IAM passwords should contain symbols, should contain lowercase, uppercase, and others. Cool. Okay, let's fix this. Just gonna remove this. And one more time, run the Snyk IAC tests. And we should see this yellow 9 medium decrease. And yes, we did fix 4 misconfiguration with our Terraform file. This is great. Cool. So what happened? So if we have a look at some of the this misconfiguration, so we have some info here, and we have a link, which is the rules that we're checking against. Cool. So if we have a look at these rules, so we've been using those. I was using the IAM password policy as an example. But basically, if you click on one of them, they'll redirect you to this website where you have all the IAM rules that you can set through code using IAC. And also, you can see that you have all of the services from AWS that you could potentially use, and you have it for Azure, for GCP, for Kubernetes. And we're checking against the CIS benchmark. So CIS stands for the Center for Internet Security. And this is where we're checking against those rules to enforce it. Cool. So if just come back to this one, so for example, the IAM password should contain lowercase. So this is saying that you should have lowercase characters. And again, this depends on your InfoSec password policy that you have within your company. And then you can enforce it through code. So they're letting you know the impact and how to resolve it. So in that case, you should have the flag set up to true. Cool. Okay. So now that we have a better understanding and we have a more global view of the modern application, which being a new risk profile, because we've seen the application code level, which is only 10 to 20% of our code base, but then we have on the lower level the open source libraries, the containers, and the IAC that also bring vulnerabilities and expand your attack surface. And we've seen that it's important actually to have guardrails at each stages of your pipeline to spot these vulnerabilities as your attack surface is getting bigger. So I've demonstrated through the coding stage that you could use the Snyk CLI or your ID integration, and as you code, you can actually test and fix those vulnerabilities. But also, if you wanted to have those guardrails set up on your repo, so you want pull request on GitHub. Also, you can integrate it in your CI/CD pipeline. So this depends if you're using a GitHub Action, Jenkins, GitLab pipeline, or Azure pipelines, and all of those, like depending on your implementation. And you have the production side also with Docker, Kubernetes, and the registry. So you can add those guardrails at every stages. And it's important to have that DevSecOps feedback loop, because it's empowering developers to build applications securely within the entire development process. We don't want to have siloed team between security and development teams. So some tips to help you having this defense in depth and thorough practices and tech to consider. For the open source level, inventory your open source components. It's important to know which components you have, and don't give hackers more tools to expand their exploits. Leverage the security tools. There's plenty of tools actually to improve your open source software security postures, and we've demonstrated with the Snyk tool suite. Embrace automation, because we don't want to have manual activities for that. include in your security policy open source software components in use, and also start having software bill of materials which identify software package contents and license data. So I'm going to demonstrate also how to use Snyk to actually create your SBOM. So I'm using these commands, Snyk test with --JSON. So you can also use the serif format if you prefer this. I'm using the Snyk to SPDX package. I'm using JQ just to query the format, the JSON format. Oh. Let me try on. Oh, let me try on another one. Oh, that's the demo monster. Oh, here it is. It's working. My bad. I didn't use the right one. Cool. So what we have here is JSON format of the SBOM. So what you could do is, if you have a centralized place where you have all of your SBOM, you can actually fetch all of this information using Snyk, and it will feedback to this and just help you populating this this SBOM. And as I mentioned, you can use the JSON format or the serif format. Cool. At the container level, obviously don't run as root. You probably don't need it. Don't use privileged containers as well. Drop capabilities, dropping all and allowing only what's needed. Have read-only root file systems, and deploy from known sources. Also pull from known registry onlys. And you can use the Snyk advisor just to see the health of the images. And from the IAC level, secrets, use them, but make sure that they are encrypted. Also use the role-based access control. Hopefully everybody is using this. Use the security context to make sure that you're not running as root. You can also start with the zero trust architecture as your network policy, and also enforce all these rules using the open policy agent like Gatekeeper or Kivino from, those are tools from the Cloud Native Computing Foundations to have those policy engine management tools to enforce those. Cool, let's finish with my top 3 tips. So first one, adopt a DevSecOps approach. So this is the shift left approach. Obviously, this is not only for the left side of your pipeline. Obviously, you want to consider all your pipeline, but the importance to have the shift left approach allows you to detect security holes from day one, and in order to prevent security issues to begin with and to resolve them as quickly as possible if they do indeed arise. And DevSecOps enable dev teams to spot security issues at all stages of the software supply chain, from design to implementation. 2, address open source vulnerabilities. We all know of open source software components, and the ecosystem is great. We're using it every day, but we need to address the vulnerabilities. We need to regularly update and patch the vulnerabilities as quickly as possible. And security training for developers, because developers are also responsible for pushing code into production. So it's critical for them to receive training from security team, or also to upskill and better understanding what is happening within their code base. And obviously the training should be tailored to the specific dev's role and security needs. This is actually a nice segue to the useful resources. I'll finish on that. So we've produced a lot of cheat sheets. This is part of the Snyk security resources. We have some around the NPM security best practices, React security best practices, and we also have around Docker and Log4Shell remediation cheat sheets. So really great reads and top 10 just to have a look at and try to implement it and improve the security hygiene of your code base. Snyk Learn, as I've demonstrated, depending on your ecosystem and programming languages, you probably will find lessons around vulnerabilities. Today we've discussed about directory, traversal, product collision, and cursive scripting. You'll find lessons around those. And finally, the State of Open Source Security 2022. This is a joint effort with the Linux Foundation Research and Snyk to talk a little bit more about the current state of the open source software security and methods to address and improve your cybersecurity postures. Amazing insights and metrics, really good reads that I would strongly recommend. I'm Sonia Moiset. I'm a senior security advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I'm doing also a lot of things outside of Snyk, but I'm not going to bore you with that today. If you want to reach out, ping me on LinkedIn at Sonia Moiset. And I hope you learned a few things today. a little bit more around vulnerabilities within the JavaScript ecosystem, Docker and IAC. And yeah, thank you for attending this session today, for tuning in. And don't forget to stay safe in your journey to cloud native application security with the help of Patch. Thank you all.
Awesome. Really well done, Sonia. Thank you so much. And we will end it with that. Have a good day, everybody.
Bye.